Okay, dear student, today I will discuss with you gravitation, and which is also very important topics. So let us discuss the gravitation. Okay. So this topic is generally not seriously taught by any teacher, or any student does not study this topic very seriously is there. But so many questions are being asked in this topic. So first we study Newton's law of gravitation. Newton's law of gravitation. And very simple statement is there. Radius is r. So F is G m1 m2 by r square. So very simple formula is there. So that is, if two point masses are in contact or it is separated by certain distance, then what is the force of attraction? So this is known as Newton's law of gravitation. That is this Newton's law of gravitation, where G is known as universal gravitational constant. So the question is there, this is gravitational constant, and along with that also this is the universal word is there. So what is the meaning of this universal word is there? Sometimes a student does not know what is the meaning of universal word at that point. वो समझता है कि भैया एक जगह मैंने पूछा तो बताया कि सर its value is same at every places and you are talking about universal. Answer is no. See, universal word means that is, you cannot go for the density of these masses are there. Density will change, then mass will change. So what I'm asking you, if you are taking 1 kg, if you are taking another is 1 kg, then if it is kept at a distance of 2 meters, then whatever the objects, all will have the same force of attraction. So hence it is word used is what? Universal gravitational constant. यानी हम लोग किस टाइप का मटेरियल है उस पर नहीं देखते. It is independent of the type of material. It comes only for masses. So now first going any further thing, we are talking about what are the limitations of this law is there, or under what condition it can be used. So main points of Newton's law of gravitation. So first is, it can be used only for point masses. It can be used only for point masses. यहाँ पर हमारा क्या होना चाहिए? Point mass होना चाहिए. For extended mass, integration is required. For extended mass, integration is required. So integration is required. So you cannot use this formula directly, right? If for example, suppose one mass is at this point and there is a rod, mass M, and this is the uniform rod, separated by the distance d. So find the force of attraction between M and the rod. So see, now this question cannot be done directly because it can be applied only between 2 point masses. So at a distance of x, let us take a small part dx and its mass is dm. So the small part is dx, its mass is dl. Now, so df, so g m dm by x square, and from where to where? X to L. So we are going from x to L. So this is from D to L, is it right? So x is varying from where to where? D to L. Now how light at the small mass dm? So see, L length will have mass m. So dx length will have mass m by L into dx. So let us substitute that. So it will be d to L g m by L dx upon x square. So very simple calculation will be there. G m by L, and this is minus 1 by x integration d to d plus L is there. At this point also d to d plus L. So d plus L is there. Right, because L is the length is there. Okay? So ये L is the length from here to here. So this is very simple. G m by L 1 by d minus d plus L. So this is the force. So this is the force of attraction between this mass and the rod. See, sometimes what is happening? कुछ बच्चे center of mass का use कर लेते हैं, but you know center of mass cannot be used in this case here because it varies a square of the distance, and we can use center of mass only when any physical quantity varies linearly on distance. Okay, linearly on distance. So that is the first what I have taught you. It can be used only between 2 point masses, right? It can be used only between 2 point masses. And if there is any extended mass, right? So if there is any extended mass, then you have to take the help of integration, right? You have to take the help of integration. Now, the second property I am going to teach you. What are the main points for this? That is, it can be used. So it can be used only between 2 point masses. Point masses. In the case of more than 2 masses, superposition principle is applied. That is, F is F1 plus F2, right? So it can be used only for 2 point masses. If you have more than 2 point masses, then superposition principle you have to apply to find the net force. Next, it is always attractive in nature. It is always attractive in nature. That is, between two masses, never repulsive force will be there. Always attractive force, right? And attractive force is always towards the object. So all attractive force is towards the object. So suppose if this is there M1 and this is your M2. So A is attracting B and B is also attracting A. So this is their attractive force. This is F1. This is by B on A, or this is F2. This is by A on B. So this is the attractive force. The direction of force. The direction of force is always in the direction of line joining the masses. All such type of force is known as central force. Means they will be always towards each other as the central force, and all central forces are conservative in nature, and hence it is also a conservative force. So gravitational force is a conservative force, right? Next, the force between two particles does not depend on the medium between the objects. So see, अगर हमने दो ऑब्जेक्ट लिया और उसके बीच में तुमने पानी रख दिया, ग्लिसरीन रख दिया, या वैक्यूम है, so the force of attraction does not depend on the medium. यानी अगर हमारे पास वैक्यूम है तो अभी उतना ही फोर्स लगेगा जितना हमने दोनों ऑब्जेक्ट को पानी में रख दिया. So it is independent. So particle does not depend on the medium between the objects. Then it is an action-reaction force. It is an action-reaction force. Sometimes people are thinking the Earth is very huge, so it is applying very strong force on us because our masses are very small relative to Earth is. But answer is no. अर्थ जितना फोर्स से हम लोगों को खींचता है, we are also pulling by the same magnitude of force the earth is also. But still its impact is different. क्योंकि अर्थ का मास बहुत ज़्यादा है, its acceleration is very less. Right? So what I'm asking, I'm not asking the acceleration is the same, but forces are the same. Right? So it is an action-reaction force. So suppose if mass m or this is mass 10 m. So B is applying a force on this F1, or this is your F2. So this is by B on A, this is by A on B. See, although this is 10 times, but you can say in magnitude both are the same thing. Clear? So this small formula F is equal to G m1 m2 by r square, which I have started initially, it can be applied only between 2 point masses. For extended mass, integration is required. It is an acceleration force. It is always attractive relation. It does not depend on the medium between the two particles. In the case of more than two particles, superposition principle is applied. That is, the force expressed by one particle, which there are several other particles are there, then it is the vector sum. And then I am giving you this introduction class for this, and then later on I will extend for this class. Okay, thank you for today's class.